Okay, so before we get into the problem that I want to look at here, I want to actually review a thing and point out when I first teach integration by substitution in Calculus 1. There's a little story about Goldilocks and the three integrals. Goldilocks, which she's doing with her, going about evangelizing the three bears' house. She's first of all runs into something in 4-H. I think it's two chairs. One was too hard, one was soft. It was too soft. One was just right. Right. 4-H was too hot. Then it was too cold. And baby bears was just right. Well, in the integration process, we have integrals that we need to do by substitution that are just right. Meaning that, as we did in the previous two examples, when you do U and U and look at what's in the problem, it's just right. You have the variable part you need, and everything works out fine. You're able to handle it. Substitution goes through flawlessly, and you eventually get to an answer. So that's the baby bear integral. Now, those are the ones we like because those are the easiest ones to do. Okay. Then we get to the mama bear. Right? We get to the mama bear integral. And that would be something like this problem right here. The square root of 9 minus x squared dx. Right? You try to do your substitution, u equals 9 minus x squared. And you say, I need a minus 2x dx. Unfortunately, I just have a dx and I don't have a minus, I don't have an x. Right? It's not enough. It's the mama bear integral. So something we just never will be able to do. This particular one is one we actually can do. We will be able to do it here later on in Calculus 2. But we need something else. Think of the mama bear's porridge. Right? It was too cold. And so we need to know how to heat it up, how to get it cooking so that it's edible. Right? We don't want to eat cold porridge. And then finally, there is the papa bear integral. There's the papa bear integral, where you actually have too much stuff left over. Too much stuff left over. In this problem here, an integral x squared root of 4x plus 7, very similar to what we're going to do in a moment. We do that u be 4x plus 7, and we'll do the derivative, we just need a 4dx. The problem is, if we do that, there's our u here in blue, there's our derivative, we still have this extra piece left over. It's too much. So this is what your textbooks generally call a change of variables integral. Right? But it's really just integration by substitution. So we have to deal with this other piece. Unlike mama bear, when we need to learn how to cook, to be able to work out a problem, we can kind of blow on the mama bear integral and pull that down. If we have too much stuff, we can deal with that. So that's what this next example is going to be. So this is the papa bear. The mama bear, which in normal calculus substitution techniques, we just can't do anything about. We will learn how to do some of those, though, using other techniques here in this course later on. But the bigger bear, which is the one we really love by substitution, is it's just right. Now let's look at when we have too much stuff left over. So our example very similar to the one I just showed you. It's x square root of 4x minus 5. X square root of 4x minus 5. So we begin our problem. It's just like we normally would. Right? So actually, I'm going to do a little rewriting first. X, and rewrite that as 4x minus 5 to the 1/2. You very clearly see how it's a composite function. and my dx. So we do our normal substitution. U equals 4x minus 5. U equals 4x minus 5. du, and then we'll call for a 4 to go with our dx. So when we look at this here, the 4x minus 5, that's going to be coming into our u piece completely. We then need a du piece. And we have some of that. We have the dx, but we're missing the 4. That's easy enough to fix. But then we have this x that's going to be left over. So what we actually have to do is take that equation there. U equals 4x minus 5, and we need to solve that for x. So that we can change the x that's left over into a u. So we do that by bringing 5 over and dividing by 4. So the x equals u plus 5. All that divided by 4. And again, that's going to come into play here when we're looking at that x that's left over. Okay. So that's kind of the setup. And now we just need to fix the dx, because we're not quite there. We have a red piece now. We have a blue piece. We're going to have to account for the green. So I need a 4 to go with it, so I can divide by 4 on the outside. And I have my x. 4x minus 5 to the 1 half. Now I have my 4 to go with my dx. Everything is set up now and ready to go. We can transition everything over from x now to u. And that's what we do. That's what we do. It's going to become 1/4 times u plus 5 over 4 times u to the 1 half times du. Now it's just a matter of cleaning this up. So I'm going to do two things here in this next step to get it ready to integrate. I'm going to bring the other 4 out. So that gives me a 1/16. And then we're going to take this u to the 1 half, the single u, and distribute it into the quantity u plus 5. So u to the 1 half times u will be u to the 3 halves. U to the 1 half times 5 will be plus 5u to the 1 half. du. And now this is set up and ready to go with the power roll and our sum roll distributing through the two pieces. Don't forget that the 1/16 is going to go with each piece. So this will be 1/16. And then we do an inner roll of u to the 3 halves. So how that works, power roll, so we add 1 to it, and then divide by it. So add 1 to the 3 halves, we'll get 5 halves. When we divide by 5 halves, we become 2/5. So we're going to have 1/16 times 2/5 u to the 5 halves. Plus, here we now have the 1/16 and the 5, so that's going to actually be 5/16. And then we use our power roll on u to the 1 half. We add 1 to it, which will make that 3 halves. And divide by it, which will be the same as multiplied by 2/3 u to the 3 halves. And plus c. And now we're in the home stretch of this problem. Because now we just need to clean up our problems a little bit and convert from u back to x. So 16 and 2 will cancel. So that's actually going to give me 1/40. And then 4x minus 5 to the 5 halves. 5/16 and 2/3. The 2's will cancel. It's a 16. So I'm going to have 5 over 24 times 4x minus 5 raised to the 3 halves. Now we managed to do our Poppy-Bear integral, which again is much more complicated. The baby bear shows right integrals because we have to make this change of variables. And as usually leads to a more complicated integral and more complicated answer. But if you were to go through, and it would be a bit of work, you see there, and do this derivative of this stuff, upon simplifying it, you would get back to your original answer, which is x squared root of 4x minus 5, upon simplifying that at the end. Okay? So again, that's the harder one, where we have some extra stuff left over with the integration by substitution.